Okay, we'll just wait a few more seconds before we start, just while people start filtering in to join. Okay, let's get started. So, hello and thank you for joining us today. This is the third webinar in this four-part series where we dive into each of the 4 domains of the AWS Certified Solutions Architect Associate. Now, the ultimate aim of this series is to provide more of an in-depth and guided understanding as to the various topics and services that you should be familiar with when studying for this exam. The exam guide can sometimes be a bit vague. I don't know if you've had a look at it yet, but when you read through it, it can be quite vague sometimes. So hopefully these webinars will answer a few questions you may have before you go and sit the certification. So today's focus is on domain 3, which is design, secure applications and architecture. And it comprises of 24% of your total score. Now, if you have any questions as we go through the webinar, then please use the chat window to submit them, and we'll get to as many as we can as we go through our Q&A section towards the end. So as always, let me start by introducing ourselves on the panel. Today, I have back with me Will Meadows, who's a senior content creator here at Cloud Academy.
Hello.
Hi, Will. You joined me back on Domain 1 a few weeks ago.
That's
So
right.
thank you for joining me again for Domain 3. It's great to have you on the call.
Yeah.
We've got a lot to talk about, so it's always good to have someone else to bounce ideas off. And of course, myself, Stuart Scott, and I'm the AWS Content Security Lead here at Cloud Academy. So let's take a look through the agenda for today. There are 3 subdomains of Domain 3, these being design secure access to AWS resources, design secure application tiers, and select appropriate data security options. So like I say, we've got quite a bit to get through, so let's get straight into it, starting with subdomain 3.1. Now, the first element that I want to talk to you about today is EC2 key pairs and how they are used to control access to both your Linux and Windows EC2 instances. Now, if you've ever provisioned an EC2 instance, and likelihood you probably have, then you've probably also worked with key pairs as well. But for the exam, you need to ensure you understand how they work. And the primary function of the key pairs are to encrypt the login information to allow you to securely connect to your instances. And the key pair itself comprises of a public and private key. Now, the public key is stored by AWS, and we as the customers are responsible for maintaining the private key. And without that private key, you are unable to connect to your instance when it's provisioned. So you need to make sure that you don't lose it. When you create your key pair and when you create your EC2 instance, you have the option to download that key pair. So make sure you do that. Now, if you have a Windows instance, then the private key is actually used to decrypt the login credentials, such as the username and password, allowing you to enter that information into the Windows login page of the instance. However, when connecting to a Linux instance, the private key is used to decrypt your credentials via SSH. So although it's a very kind of simple principle, understanding the key pairs and when you might need them and how to use them is essential. Is there anything else you would add onto that, Will?
Yeah, I know when I was first getting started, just with my tech career in general and also for cloud, understanding that using the key pair on Windows is unlocking those Windows specific credentials and then plugging them in to the remote desktop client that you may have, whatever RDP thing you've got going. And that's what terminals you into your instance. And then it's like you're looking at the box right in front of you, like any other remote desktop. It's important to have those two sort of distinct in your mind, the 2 modalities. One is SSH through the terminal, as you would on a Linux box normally, and the other one is RDP.
Yeah, exactly. There's always a lot of keys when talking about AWS. It can be quite confusing sometimes.
Oh yeah,
So
moving on, remote desktop protocol. Sorry.
Yeah, remembering all those acronyms as well. So let's now move on to IAM, which is Identity and Access Management. And I think it's absolutely necessary to have a solid understanding of the differences between IAM users, groups, and roles. So, Will, do you want to run us through each of those and just pick out some of the key differences between them?
Yeah, I mean, the nice thing about IAM is it's a fairly well-named service, which is sometimes hard to come across in Amazon land. So users, they're exactly what you would expect. They're sort of this logical idea that some entity, probably a human, will have control of some amount of something within Amazon. Usually these are people within your organizations that you would give access to various things like EC2 or S3 or DynamoDB. Um, and they're very configurable. You can give people varying levels and degrees of access to these topics. For example, DynamoDB allows you to give fine-grained control all the way down to the table level and the item level within. So that's pretty nifty. Let's see. Oh yeah, and you can also have MFA. Always turn on MFA for your users. So the next sort of like logical hierarchy in this structure would be groups, and you probably already hit the nail on the head. But a group is just a collection of users, and if you were to apply permissions to a user, sort of on a one-to-one basis, you could do the same for the whole group as well. So if you wanted to make sure no one ever had the option to delete a database, you'd put everybody in the please do not delete database group, and then you could apply that permission onto that whole group, and everyone below would be affected by it. Roles are sort of this own special thing within Amazon that allow you to adopt temporary credentials, almost like you're a completely different user. Let's say you had a role that maybe only gave you access to do that deletion thing. Maybe you never want a human to normally have access for the delete all tables or delete all databases API call, but maybe sometimes you want your admin to be able to do it, but you don't want them to be able to do it on accident. So you create a separate role that they have to assume in order to gain those credentials and those powers to do so. One of the other neat things about roles is services and other applications that you have can also assume roles and do things on your behalf. It's very important to know the distinction between these three ideas. Let me see. I think that's a pretty good wrap up of
Yeah,
these
definitely,
three.
definitely. Um, so it's I think it's essential for every certification, not just solutions architect, literally, to have a real good grasp of each of those. So for users, just to reiterate, permissions can be added to users, but it's not always best practice. Permissions should really be added to groups, and then you add those users to groups just for better administration.
Hmm.
And like Will said, that the roles can be attached to services such as your EC2 instances, or assumed by other services or by users. And again, just be familiar with the different types of roles. So the best thing I find with IAM is just to have a play. So if you have got your own AWS account, create some dummy users and groups and roles and just have a play around and see how they respond and see what kind of effect it has, just so you understand how the permissions work. So moving on from that then on to programmatic access using keys. Now I kind of briefly mentioned this a minute ago. When I first started using AWS a few years back, for some reason I always got confused between key pairs, which we just spoke about, and access keys and secret keys. For some reason, when being new to AWS, it just seemed like there was a lot of keys going on, and
There are a lot of keys.
I just couldn't get my head around it at all. And that was before even using the KMS service, which pretty much consists of keys. So it can be quite difficult to get your head around it when you first started get into it. But anyway, back to the point. With programmatic access, users can be granted access to your resources using two different methods, via the AWS Management Console and or via programmatic access. So if you have an IAM user account, you'll be able to log into the console and access your resources and do whatever you need to do. But if you also want that same user to utilize your resources and maintain them programmatically, for example, through the CLI, without going through the management console, then you need to have access keys generated for that IAM user account. Now, the keys themselves, they consist of an access key and a secret access key. So that means when you configure your AWS CLI, you'll need to provide this set of keys to ensure your client knows what your user permissions are when running different CLI commands. So the keys permit the same level of permissions that you would receive if you logged into AWS via the AWS Management Console effectively. So they're very different between key pairs with regards to your programmatic access. So just make sure you know the differences between those.
One fun side note is if you're working in the CLI and you swear you've got the right keys in there, but the things you're trying to do don't feel like they're actually making effect that you can see in the management console, make sure you're in the right region. That's like the biggest tip I'll give you for like the rest of your development life. So, regions play a key role in making things happen the right way.
Okay, so next up we have IAM policies. And it's these policies that really determine what you are and aren't allowed to do within your account. Now, as with most other policies within AWS, they are written in a JSON format, JavaScript object notation. And now it's really important that you can learn to interpret these policies. So make sure you spend time examining them to understand their syntax and their construct. The policy itself will contain at least one statement, and this will usually have an action, an effect, a resource, and optionally a condition parameter as well. So the action defines which API calls are being applied to the policy. The effect is the element that can either be set to allow or deny access to the APIs that are defined in the actions. And the resource element specifies the actual resource that you want the action and effect to be applied to. And this is typically an ARN of a specific resource. So make sure you have a grasp of the differences between AWS managed, customer managed, and inline policies as well. So there's a number of different types of policies and how they can be applied. And you need to know the difference. So just as a quick recap, for those that haven't kind of played around with policies, AWS managed policies are those that have been pre-configured by AWS. So they're already built, they already have all the permissions there. It could be something like S3 full access. So if you search for that, there's already a policy there that's been created by S3, and you can just apply that to your group or your role. To save you having to build your own. And then you have customer managed policies, and these are policies that you can create yourself. They could be very specific. If there isn't a policy in the AWS managed list that you need, you can just create your own and save it and have it very customizable. Now, both AWS managed and customer managed policies can be applied to users, groups, and roles. However, inline policies are attached directly to user objects. So be familiar with what inline policies are compared to the others. And probably one of the most important things to remember for the exam is that an explicit deny in a policy will override any previous allow that relates to the same resource. Have I missed anything there, Will, that's kind of fundamental?
I remember when I was studying for this exam, it sounds kind of silly, but action, effect, and resource spell out ear. And that sounds, it sounds funny, but if you're looking through one of these policies and there's a question, make sure that the policy has all of those three things for it to be effective. It must have a thing it's going to do, what it's affecting with that thing it does, and the resource that all of it will be applied to. So make sure you check that out for when you're looking at these policies.
That's really cool, actually, that whole ear thing. I've never really thought of it that way.
And that really screwed up my joke, but I'll take it anyway.
That is optional, though. The condition is just optional, so that's okay.
Some people have ears, some people don't,
So, Will, do you want to take us through some of the things to remember if you're configuring cross-account access from an IAM perspective?
Yeah, it's mostly a pain, but it's not too hard to do. So what you do, if you want to have access to someone else's account in some fashion, let's say you wanted to monitor your intern and see how many EC2 instances they may or may not be spinning up for no reason. You could request having access to that function, that API call, see EC2 instances in their account. And the way you would do that is you have these two ideas. You have a trusted account and you have a trusting account. So the EC2 intern who you're going to be monitoring, they're going to be very trusting in you. And you are going to be the trusted person that they're going to give access to. So that's one way to think about it. And what they would need to do is set up a role for you to assume from your account. And the roles that we spoke of earlier, again, can be assumed by humans or resources. And what that allows you to do is from your side, you can access their API calls on their account and be able to see, just like you are one of their users under their admin account, what instances they have over on their side. So it's a very powerful tool for doing very specific things, although it can get very confusing because one of the big limiting factors is making sure that you have the ability to do cross-account access through, we'll go to it to the next slide, but something like SCP control policies might block you if you're not careful.
Nice, very well put, Will, thank you. And here's those SCPs that you just mentioned. So next we move on to AWS organizations, and more specifically for this section, the service control policies, the SCPs. And these are used to help control access across your AWS account when using AWS organizations. Now, for those that are unfamiliar with AWS organizations, it effectively allows you to essentially manage multiple AWS accounts and helps you to meet security and compliance requirements through a hierarchical structure of accounts, essentially. Now, as you can see on the right-hand side of the screen, there are three different elements to AWS organizations from a structure point of view. You have the root, which is right at the top, the OUs, which are the organizational units, and then AWS accounts. Now, the service control policies allow you to control access to services and features that can and can't be used. And these are then applied at a specific layer in your AWS organization, for example, at an OU level. Now, I want to be clear that service control policies do not actually grant permissions to resources. Instead, they just act as a boundary of what level of permissions can be applied within your accounts. And as a result, they take precedence over any IAM policies you might have applied to your users within your different AWS accounts. So say, for example, you had an IAM user who has full access to S3 from an identity-based permissions granted through IAM. However, if that account that the user belongs to was controlled by a service control policy that denied access to all S3 APIs, then that user would not be able to access S3 despite his IAM permissions. So SCPs essentially act as a central security control for either a single or multiple AWS accounts. Do you have anything to add?
There's also a what was the other layer they've added to this to make even doing organizations easier? Was it a control tower? Is that the one for
the service?
Yeah,
service, yeah, control tower, yeah.
There's more levels to all this. Of that might be on the exam these days. I don't remember. It might be just old enough to get on there. Something to look at.
Awesome. Okay, I know architecture is one of your favorite subjects, Will. So do you want to take this slide that focuses on some of the VPC security controls?
Sure. So we've been talking about permissions for users and groups and whatnot. That's all fun and good, but sometimes it's really important to think about the permissions for your packets to be able to get into your network and your architectures and your virtual private cloud. So one of the most obvious, or one of the first, I should say, security mechanisms you'll come across when you make an instance in general is a security group. And these groups are sort of what defines and allows traffic to flow into your instances. The security groups operate at it's kind of like a firewall. They operate at the network card level on the instance. This is different from NACLs, which I'll explain later. And what that means is these security groups contain the set of rules which allow inbound and outbound traffic into and out of the EC2 instance. If there's no rule that explicitly permits the packets from getting in, they will be dropped, of course. And these guys, again, this is a key feature of security groups, are stateful. And just to read off the slide, it means you don't need to add rules for the return or the response traffic. So it just sort of assumes that if you allowed the thing in, you'll probably want to allow the thing to talk back out to that same origin that it came from. So if we talk about NACLs or network ACLs, one of the key differences between this and security groups is these operate at the subnet level. So when traffic is working its way through your infrastructure, the first thing it will hit is the subnet in this relationship. So NACLs have a little bit more purview and strength over a security group. That doesn't mean I'm recommending to use them because they can be a little bit more confusing. They're basically a stateless system that you have to have explicit rules for to allow traffic to come in and out of. They're very brutal. But one thing they do allow you to do is sort of blacklist and whitelist traffic that you may be afraid of. So let's say you're getting a hellacious DDoS attack. You can't really stop that super well with security groups because security groups are fairly dumb in that they only sort of allow traffic in. If you want to stop specific IP addresses from harassing your network, this is where you could do that, is in the network access control lists. So something interesting to think of. Oh yeah, an important key, the rules are read in ascending order, so make sure you get your order of operations, and explicit deny usually does sort of trump everything here as well. Yeah, did I miss anything in those two? I think that's a good compare and contrast between those guys.
Yeah, definitely. Yep.
And so between all of that, we need a way sometimes to have private instances, ones that we don't want being talked to or being chatted with the outside internet, to go get updates reliably. And back in the Dizzle, you might have had an instance all by itself that's entire job was to help hop traffic out to the internet and bring back updates for it. It would be called a NAT instance. In recent times, AWS has decided to help manage that problem for you because it's both not fun and it's just another thing you have to manage. So AWS has these things called NAT gateways. We have an internet gateway. We've also got a NAT gateway, and it provides that secure connection that's managed. That means AWS deals with it for you out to the internet for your poor private subnet instances that just desperately want updates. And one of the big things with the NAT gateway is all of your traffic from your private subnets filters up through to the NAT gateway, as long as you point in that direction, and can go out and go grab whatever it's looking for and come back with the peace of mind that everything that's behind the firewall, behind in your private subnets, will be secure. I think that's a good touch. Do you have anything else to add there?
No, I think you covered it. Some people are sometimes confused as to how the traffic initiation works. So the NAT gate will only accept connections that are kind of from within your VPC. It will never accept or initiate a connection externally inbound. It always has to originate from inside your VPC and go out. So that's just another level of protection there. But yeah, I think you nailed it.
Sorry, a bit rambly.
Rambly is good. More information, the better, as far as I'm concerned. Okay. So that has brought us to the end of the discussion covering some of the topics that might appear in relation to how to design secure access to your resources. Now we move on to the next subdomain, design secure application tiers. And we're going to start with using secure sockets layer SSL in application load balancers. When using an encrypted protocol as a listener for your elastic load balancers, such as HTTPS, it will require some additional configuration. And this includes the presence of a server certificate and an associated security policy. Now, the server certificates used by the application load balancer, the ALBs, is an X509 certificate. And this is a digital ID that's provisioned by a certificate authority. And this certificate authority could be the AWS Certificate Manager, also known as the ACM. If you're not aware of that service, go check it out. Just go and read about it, just so you're familiar. And this certificate is simply used to terminate the encrypted connection received from your remote client. And as a part of that termination process, the request is then decrypted and forwarded to the resources that you might have in your ELB target group, for example. Now, when you select HTTPS as your listener, you'll be asked to select a certificate using one of 4 different options, and you can see those on the screen. So you can choose the certificate from ACM, upload a certificate there and then to ACM, choose a certificate from IAM, or upload it to IAM. Now, the first 2 options relate to ACM, and ACM allows you to create and provision SSL and TLS server certificates to be used within your environment across different AWS services. Now, this integration with ACM simplifies the whole configuration process, and so it's the preferred and recommended option. So just be aware of that. The ACM integration with ALBs when it comes to server certificates, it's the ACM that's the recommended option because it's an AWS managed service and just makes everything a lot easier. The last 2 options allow you to use a third-party certificate by using IAM as your certificate manager. And this option is generally used if ACM is not supported in the regions where you are deploying your ALBs. So that's the only reason you'd probably use the IAM option over ACM. So if you're unfamiliar with deploying application load balancers, then again, get some hands-on experience and just play around with different listeners, and especially those that require a server certificate. Anything else there, Will?
Yeah, one thing about the certificate manager for the private certificate authority pricing is it's $400 a month for that direction. So it's something to bear in mind, is it's not free for private certificates.
Yeah, maybe don't play around with it too much then at that price, eh? Okay. So let's take a look at the AWS Web Application Firewall, known as WAF. So the main function of AWS WAF is to provide protection of your web applications from malicious attacks, and this comes in the form of a wide variety of different attack patterns. It's also used to identify how Amazon CloudFront distributions and, again, application load balancers respond to web requests, and this is based on specific criteria and conditions. Now, the services work together to filter both HTTP and HTTPS by distinguishing between legitimate and harmful inbound requests that will then either be allowed or blocked. There's 3 main points that you should be aware of when it comes to WAF. These being the Web Access Control List, the rules, and also the WAF rule groups as well. So the Web ACL, the Web Access Control List, this can be considered the glue that essentially holds all the other components together and is the main component of WAF. It allows you to define a protection strategy for your AWS resources in your account, and this is done by adding rules to it. And these rules define an action for the traffic, which is either blocked or allowed after inspecting each request. Now, moving on to the rules themselves contain statements which identify what criteria should be used to inspect any incoming requests. And the result of that inspection ends with a corresponding action. And if there is a match to the rule, it will either allow, block, or count it. And there are 2 types of rules, regular rules and rate-based rules. Now, the only difference between a rate-based rule and a regular rule is that the rate-based rules count the number of requests that are being received from a particular IP address over a time period of 5 minutes. And then when that count limit is reached for a rate-based rule, and you can customize that, then all other requests from that same IP address is blocked. And then we have the rule groups. Now, the primary function of the rule groups allows you to create groupings of existing WAF rules. I think that up to a maximum of 10. Correct me if I'm wrong, Will, but I think that's what it is. And all of these are within the rule group that have the same actions applied when the conditions of the rules are met. So again, allow or block. Now, you can either define and configure your own rule groups from using your own WAF rules, or, and which might be easier and save you some time and configuration, you can use rule groups managed by AWS that have been, and some of these have been put together by third parties as well, so you can get them off the AWS marketplace. Now on the screen there, you can see a few examples just in that white box of some of the rule groups that are created by AWS that could be selected, but there are tons of them available. So there's probably a rule group there that will be very useful for a particular use case that you have. So feel free to take a look at all their rule groups.
Yeah, you have it on the screen, the SQL database one. This one's super special. I highly recommend anyone who has to deal with databases or security minded to take a look at them. Because I mean, these type of attacks change. I mean, they're the same in general, but the way they operate changes over time, and it really sucks to have to spend valuable, development time or whatever it is you want to do with the rest of your day, researching what the latest and greatest way that someone's trying to, bork over your system is. So having a thing you can press up, just a button, it's just a button click and say, I want this to happen, these SQL injection attack defense, and have AWS manage that, and you don't have to really think about it too much. Don't not think about it, but is very powerful. It's what is it that Amazon likes to say is that it removes some of the undifferentiated heavy lifting involved with building things. So I like that a lot.
If someone else is doing it for you, then it's generally a lot easier.
Yeah.
It saves you a lot of time. So moving on from WAF, what do we have now? Firewall Manager. So this closely relates to AWS WAF that we just spoke about. So Firewall Manager was essentially designed to help you manage WAF in a multi-account environment with simplicity and control. And it allows you to protect your vulnerable resources across all of your AWS accounts within your AWS organization. And we spoke about organizations earlier. It can group and protect specific resources together. For example, all resources with a particular tag or all of your CloudFront distributions. Now, before using Firewall Manager, there are a number of prerequisites that you need to meet. So do be aware of these. Firstly, you must ensure that your AWS account is part of an AWS organization. That's fundamental. But the organization that it's a part of must have been configured with all features, not just consolidated billing. Otherwise, it just won't work. You must also define which AWS account will act as your Firewall Manager administrator account. And lastly, you have to have AWS config enabled. And within Firewall Manager, there's 3 different components that you should probably be aware of again, and that allow you to control and manage your AWS accounts within your organization. These being WAF rules, rule groups, and Firewall Manager policies. Now, we covered the first 2 in the previous slide. However, firewall policies contain the rule groups that you want to assign to your AWS resources. And it's important to point out that you can only have 2 rule groups per policy, one that's customer created and one that's either AWS managed or from the AWS marketplace. Anything else on that, Will, or Firewall Manager?
No, I think that was fantastic.
Okay, let's go with that then. Okay, so now we have AWS Shield. I just want to highlight a few points of this. So firstly, what is Shield used for? Shield has been designed to help protect your infrastructure against distributed denial of service attacks, commonly known as DDoS, and I think you highlighted that earlier, Will. And these types of attacks are very common, more common than you think. And the attack itself targets a host which might be running a website or a web application, and it receives a huge number of requests simultaneously, which are obviously sent maliciously by an attacker from multiple distributed sources. And this increases the flow of traffic, and it aims to prevent legitimate requests from getting through to the host and being processed. So it severely hinders the performance of the application or website. And there's a number of different types of DDoS attacks that can take place. For example, a SYN flood, a DNS query flood, or a cache busting attack. The main point I want to make about Shield is that it offers 2 levels of protection. you have standard, and you have advanced. Now, standard is available to everyone, and it offers protection at layer 3 and layer 4, and it integrates with both CloudFront and Route 53. Now, the advanced options provide a far greater level of protection for DDoS attacks across a much wider scope of AWS services, but it does come at an additional cost, obviously. You'll also have access to a 24/7 specialized DDoS response team, which is known as DRT. And plus you also get protection at layer 7, the application layer, as well as protection at layer 3 and layer 4, like you do with standard.
Some fun facts. Some fun facts about Shield Advance is if you so Shield Advance costs quite a bit of money. It's something to bear in mind. But what you buy with that money is insurance, because if you do get hit with a DDoS attack and you have Shield Advance, correct me if I'm wrong on this one, because it might be a different service. I'm going crazy. But AWS will pay for all the load on your resources if that is a qualified AWS attack or a DDoS attack. So if someone's coming through and they are hammering your infrastructure, and you are auto scaling in the background to try to make sure your legitimate customers still have access to your resources. So maybe you go from 100 instances running to 1,000, 2,000 instances via auto scaling to stay afloat. You don't have to pay for that, and AWS will comp that hit in the back end.
Yes, that cost protection, which is awesome to have.
Oh, it's so good. One of the other things that's important to note is if you want to test out your resilience to DDoS, you have to tell Amazon. If you don't, you're breaking some sort of terms of service. So make sure you give them a call ahead of time and say, hey, at this time, we're going to hammer the defenses and we're going to see how we do. And then they will do their side as well. So some fun background.
Yeah, nice one. Thank you, Will.
Sorry, I didn't mean to steal your thunder.
No, it's great insight. Thank you. So Amazon Cognito, do you want to run through this slide?
Yeah, why not? So Cognito, this is a service that sort of fills an interesting role in that it allows you to have authentication in probably one of the easiest ways possible. There's two sort of sides of Cognito. There's these user pools and there's identity pools. What user pools allows you to do is to authenticate this person that's coming in and give them access to sort of whatever you want in your applications. This would be something like if you had a phone app or a web app and you wanted them to have access to your application, that's what user pools allow you to do. And they can federate through a couple of ways, through various identity providers like Facebook and Google and Amazon and Apple and OpenID Connect, Nito Burrito, and SAML. Everyone loves SAML. But let's say you want to kind of do the same exact thing, but you want these people to also have access, and these may be different people, to some services inside of AWS. And so you would use identity pools for that. And they give you these temporary credentials that allow whatever user you've decided to have access to. Let's say, what have I got there for icons? Code, Pipeline, one of the weird machine learning services, or CloudTrail. And then you could give them some access into your infrastructure using identity pools. So as long as you remember there's sort of like two separate concepts with Cognito, which is authentication for users, simplified, generally for mobile and web, that's the big takeaway for Cognito. It's a cool service. One of the nice things it allows you to do is also add your branding into your login. So it's manage login service with your branding to do things like allow people to use your app or to allow people to use little bits of Amazon. There you go.
Awesome. Thank you, Will. No, brilliant. Thank you. Okay. So we now move on to the final subdomain of domain 3, select appropriate data security options. And we're going to start with the key management service, KMS. So this is another service that revolves heavily around keys. It's more keys than AWS. So basically, the key management service is used to store and generate encryption keys that can be used by other services and applications to encrypt your data. And there are 3 different types of keys that you need to be aware of and how they operate. Mainly customer master keys and data encryption keys. And it's down to us as a customer, not AWS, to ensure that we have implemented adequate security measures to protect our keys. And we can do this through key policies, and I'll come on to those in just a couple of minutes. Now, KMS, although it's used for encryption, it's only used for encryption at rest only. It's not an in-transit encryption service or protocol like SSL, for example. When architecting your environment with regards to data encryption, you need to be aware that AWS KMS is not a multi-region service like IAM is, for example. It is region specific. So if you create a key in one region, then you cannot use that same key in a different region. And that's key to highlight and something to be aware of. So let me just quickly run through at a high level the four main components of KMS, and you can see them at the bottom of the screen there. So we have the CMK, and this is the main key type within KMS, and it contains the key material that's used to encrypt your data, and you should be aware of the three different types of CMK. You have customer managed, AWS managed, and AWS owned. So make sure you look into each of those and you're familiar with the differences between them. Also, a fundamental point of the CMK is that it never leaves KMS. The CMK will always remain in the service. Next, we have the data encryption keys, or DEKs, and these keys are created by CMKs. And these keys, the DEKs, can be used outside of KMS, unlike the CMKs can. And they perform encryption against your data, either in your own applications or indeed by other AWS services. Now, the CMK will generate two different data encryption keys. One will be a plain text key, and it'll also generate an identical key, but this will be encrypted. And then we have the key policies. So key policies determine who can do what with the key. For example, defining who can use the key to perform either cryptographic operations such as encrypt, decrypt, generate data key, etc. And in addition to those who could administer the CMK to perform functions such as deleting the key, revoking the key, and also importing new key material. Without a key policy, you can't control access to a CMK. And access to CMKs can be controlled in three different ways: by key policies alone, by key policies and IAM permissions, or by key policies and grants. So as you can see, without a key policy, you can't have access to a CMK. And then finally, grants. Now, grants allow you to programmatically delegate permissions from one person to another. And this can be achieved, this can't be achieved through the AWS Management Console. You have to use the AWS CLI. It can only be programmatically performed. Okay, next we have EBS encryption. Sorry, Will, was there anything you wanted to add on the end of KMS there?
Yeah, although as funny as it sounds, like when I think about KMS, one of the things that comes to mind is when you really can't use it is if you have specific requirements, governmental, regional, or otherwise, that you have to be in control of the key or your encryption thing at all times, like it can't be on a shared system. Amazon does have some options for that, which is HSM and Cloud HSM. The first one I think is being sunsetted, but you may still have access to it, which is a hardware security module that some poor schmuck in a data center, once you request it, will go plug in a physical piece of hardware onto whatever instance you're using, and you can use that as a sole source for your encryption keys. That costs like $5,000 a month, so you only should do that if you desperately need it. Luckily, there's Cloud HSM, which is Amazon's solution to not spending $5,000 a month. And it does functionally the same thing, but it's more of a logical construct.
I think that cost is gone now on the Cloud HSM.
Excellent, beautiful.
Yeah,
the original HSM was insane.
Yeah, I think originally to provision it cost 5,000, but I need to double check that. But I remember seeing something about the cost of that being removed, and it's just kind of on a utilization case. But Yeah, so don't take that for granted, but I vaguely remember hearing something about that. Awesome. Cheers, Will.
Yeah.
So EBS encryption. Again, this tightly integrates with KMS, which is what we just talked about. And it does so in a very simplistic way. It's pretty much a tick box. Enabling encryption doesn't impact or affect your IOPS performance of your volumes either, despite it encrypting both the root and data volumes. And also, as a point to highlight, is that any data moving between your instances and EBS volumes will also be encrypted. You should look into how encryption works when working with EBS snapshots, how the encryption is copied when you take a snapshot of an encrypted volume, or how you can create an encrypted volume from an unencrypted snapshot. So there's different ways you can encrypt an existing volume through snapshots, and also how you can copy encrypted volumes through the snapshots as well. So just to have a read up on that, take a look at it, and just see how the encryption method works around that. Also, finally, take a look at the default regional encryption that you can implement, which will ensure all future EBS volumes will automatically have encryption enabled. And you can see that in the bottom right image there. It can easily be configured from within the AWS Management Console, and it's simply just a tick box. Anything to add for EBS, Will?
No, I think it's fairly straightforward.
Cool. Yeah, I think that's pretty simple for EBS. Okay, next we have S3. You have lots of different encryption options and mechanisms when using S3. There's 5 different encryption options available to encrypt your S3 objects. These being SSE S3, SSE KMS, SSE C, CSE KMS, and CSE C. So some of them are server-side encryption. That should say SSE rather than SEE on the screen, so I apologize for that. So the difference between server-side encryption and client-side encryption is fairly simple. With server-side encryption, the encryption algorithm and process is run from the server side, in this instance with Amazon S3, and client-side encryption means that the encryption process is executed on the client first before the data is then sent to S3 for storage. You can see I won't read through each of those, but feel free to take a look at this when you get a recording, just the differences between each of those encryption options. But let me just run through one of those as a step-by-step process of how it works. So I'll look at server-side encryption with KMS managed keys. So at the top we have the encryption, and at the bottom we have the decryption process. So let's start with the encryption. So a client will have some data, an object data, and it will send this to S3. If the SSE KMS encryption option has been selected, then S3 will send a request to KMS to request some data keys. So when it reaches KMS, a CMK will be used that was selected, and it will generate a plain text data key and an encrypted data key. These 2 keys are then sent back to S3. Now at this point, S3 takes the uploaded object data, combines it with the plain text data key, goes through an encryption algorithm, and then we have the encrypted object data. And alongside this, we have the encrypted data key, which is stored right alongside the object. At that point, the plain text key is removed from memory. So it's the plain text key that actually performs the encryption against the object. So let's now look at the decryption process. So starting at number 1, the client will request the data from S3. S3 will see that the object is encrypted and it has the encrypted data key that's associated with it. So it will send that encrypted data key to KMS. KMS will then identify which CMK generated that encrypted data key, go through an encryption algorithm or decryption, and it will generate a plain text data key. Now this plain text data key will then be sent back to S3. S3 will take this plain text data key, the encrypted object data, go through an algorithm, and it will generate the decrypted object data. At that point, the plain text key is removed from memory. And then the object is then passed back to the client. So that kind of ties up a few of the things we were speaking about earlier with regards to KMS. We have the CMK, which generates data encryption keys, 2 keys, a plain text key, and an encrypted data key. And that just shows you how the encryption process works when using KMS. Did you get that, Will?
I did.
That makes
It's
sense?
a lot. So much
Yeah.
encryption.
So as a URL at the bottom there, I created this infographic to help people understand how S3 encryption works. And if you go to that URL at the bottom, then I'll have an image like this for every one of those 5 different options, so you can see how all of those encryption processes work.
I did take a moment to look up Cloud HSM Classic, and if you don't have it, you'll never get it again because it's closed for new customers, so you don't have to worry about it. And the new Cloud HSM is only $1.45 an hour, if that's something you need.
So it's not, you don't have that $5,000 cost anymore.
No, it's not possible unless you've already got one. So
got it.
Easy breezy.
Okay, so the last slide before we get into any questions looks at the security of EFS, the Elastic File System. Now, the first thing to mention is that Amazon EFS supports both encryption at rest and encryption in transit. Now, encryption at rest is easily implemented through a checkbox during the creation of your EFS file system, and it again integrates with KMS. I mean, KMS integrates with a lot of AWS services now, and normally it's just a simple tick box and select the appropriate CMK that you'd like to use. Encryption in transit should be used if you need to ensure data remains secure between your EFS file system and your end clients. Encryption in transit is enabled through the utilization of the TLS protocol when you perform the actual mounting of your EFS file system. And there's a command there that shows you how to do that. And the best way to do that is to use the EFS mount helper. And this will create a client tunnel process using TLS version 1.2, which is used to listen out for any traffic using NFS, which it then redirects to the client tunnel process. Okay.
We did it.
We did.
We're here.
Let's take a look at the Q&A. Do you have the screen open there, Will?
I do. If versioning is enabled, can keys be rotated? Will the prior version be decrypted using the old keys?
Yes, so AWS manages all the rotation of the keys, or it depends what key it is, but it will keep a history of previously used keys. So if an object has been encrypted with an older key and a new one's been rotated, it will have a copy of those existing keys to decrypt the data. Another question, someone's asking if we need to know that level of detail for the exam with regards to the S3 encryption mechanisms. You don't, so that diagram that I showed, you don't need to know it at that level. I just wanted to show that diagram to show you how the CMK and the data encryption keys all kind of fit together and worked. What you do need to be aware of is the different types of encryption that are available with S3 and how they differ, and aware that some are server-side encryption and some are client-side encryption.
Can you demystify the groups and rule stuff one more time? Stateful and stateless, and which and when, please. All right.
Let me get back to that slide, Will, and you can go through it.
Yeah. It's a good question.
Here we go.
All right, demystification, groups and roles. Let's go to that one first.
Oh, the group and role?
Yeah, just the one above it. So we've got our standard user, which is just your one object or your one person entity. And then a group is a collection of those one user entities where you could apply a control policy over them, not a control policy, a policy, IAM policy over them to allow them to do or to not do certain things. And then to go to the next part of the question, the stateful versus stateless. Here we go, the users, groups, and roles.
Sorry.
We're going slow today.
So now we're back on this one, yeah.
That's right. So if something is stateful, it's keeping track of who sort of sent the messages and where it's coming from. And it says, all right, if you have allowed traffic in from this place, I assume you probably want to let it go back out. If something's stateless, you need to explicitly tell it that. So you can see this example here in the NACL, that little chart we have here, where it's allowing all traffic from anywhere, but it's not denying all traffic from anywhere. I think that's how that one's running. And so that's something that's needs to be explicitly stated. Hopefully that answers your question.
Cool. Doesn't encryption make S3 slower? There might be a very tiny latency impact. I don't know of any hard and fast rules on that, but it certainly wouldn't be anything that's really that noticeable, unless it's really impactful to what you're using S3 for. But I don't think it will have anything that you would notice.
We have another question. Can you please explain client-side encryption using KMS again?
Let's have a look. Let's get back onto the slide. So we have client-side encryption with KMS managed keys and with customer-provided keys. So the actual client encryption is the encryption process itself is done on the client. So the keys are generated through KMS and then sent to the client, and then the encryption takes place on the client side, and then that encrypted data is then sent back to S3. For a visual explanation, then do take a look at the URL at the bottom, and it will be laid out very much like this, so you can follow the process step by step on that. But the main thing to remember is that the client-side encryption, the encryption mechanism will take place on the client side, and then the encrypted data will then be sent to S3. Okay, I think we've come to the end of the questions. So again, I just want to highlight that if you are studying for the Solutions Architect Associate, then we do have a learning path here at Cloud Academy that covers all the topics that you need to be aware of. It has a number of courses, hands-on labs, some lab challenges, some webinars in there as well, where we dive deeper into specific topics, and a preparation exam as well. So please do take a look at that. And finally, thank you. Thank you to everyone for joining today and for listening and for submitting your questions. If you do have any more questions or you want more information on anything that we've spoken about, then please do reach out to either Will or myself. Our details are on the screen, and we'll be happy to help. And thank you to you, Will, for joining me today.
Yeah.
It was great running through. There was a lot of content, but we got there in the end, and just within the hour as well. So it worked out okay.
Ooh, we got lucky. I like it.
So thank you very much, and I look forward to speaking to you again for the final part in this webinar series. Thank you and goodbye.
Cheers.